Hey everyone, hello. Welcome to the Kubernetes tutorials. This is part 2. If you haven't watched part 1, I would recommend please go ahead and watch part 1 and then come to this part. In the previous video, I had covered the fundamentals, the different architecture, different components. In this tutorial, we are going to go in depth for container runtime, defining what is container runtime, and pods. Plus, we are going to see a lot of kubectl command examples. All right. So let's get started. So just a brief recap of what we studied in the last lecture. This is how a Kubernetes architecture looks like. You have a master node and you have a lot of worker nodes. Master node contains different components: scheduler, etcd, API, CCM, and control manager, and cloud provider. So controller manager, sorry. And then you have different nodes. These are the worker nodes where actually your pods containing your containerized application runs. Okay. And kubectl is the one, kubelet is the one that manages those pods, that manages those runtimes. Okay. Again, everything communicates only via the API server, which is hub and spoke API architecture, which is used by Kubernetes. Okay, so and this is proxy, which is used for networking in order to talk to the API server, giving managing the security authentications. That would be the kproxy's job. Okay, so today we're going to study about the container runtime interface. Basically, at the end of the day, what does Kubernetes do? It will help you deploy, or it will provide you an infrastructure where you can deploy your containerized applications, which means applications which run as a part of container. Now, as you are aware that there's not just one container software available, right? There are multiple container software available. We have Docker, we have Vagrant, we have Podman, multiple softwares available, which provides the container environment for your application. Now, Kubernetes will allow you to host any containerized application, whether it's Dockerized or anything, Vagrant, anything, right? Now, but they all need to talk to the control manager, right? The control manager needs to be able to create the pod, destroy the pod, create the container, destroy the container. A lot of background activities, or what you call infrastructural activities, need to be done. That is why this interface is there. In normal programming concept also, or if you think about design algorithms, what does interface provide? Interface is nothing but just a contract, right? So whichever class implements the interface, the application that is using that class can be 100% sure that those methods would be implemented. The contract methods that the interface defines will be implemented. That is for sure. So that's a contract. So similarly, the container runtime interface defines a set of contracts, a set of methods, which all the providers, the container runtime providers, will have to give its own implementation, because each one will have, each container software will have its own implementation, right? So you need a working container runtime on each node in your clusters so that the kubelet, which we saw just in the previous slide, can launch pods and their containers. Launch pods and containers means initiate, create. Okay. CRI, the container runtime interface, is used by Kubernetes to manage the life cycle of containers. So that's what I was just talking about. starting a container, stopping a container, restarting, updating the entire life cycle. It also provides information about containers such as their status, resource usage, and logs. Status means whether they're up or they're up and running or they've been stopped. What is the status? It defines the main gRPC. RPC stands for Remote Procedure Call, and G is for Google RPC protocol for communication between the cluster component kubelet and container runtime. Let's see. Oh, sorry, I clicked on it. Okay. Next. That was a hyperlink. Okay. So container runtime, CRI continued. This is how it looks like. Kubelets, the tiny circle that we saw, communicates with the container runtime, okay, or CRI shim for the runtime over Unix sockets using the gRPC framework, where the kubelet acts as the client and the CRI, the container runtime, acts as the server, which means it gives the implementation, okay? And it basically what it does is whatever the kubelet is asking, it will convert it into respective container command and give it to the container runtime. And you can see these are the different types of containers that are there. The protocol buffer API includes two gRPC services, image service, and runtime service. So three things are there in the protocol buffers, CRI protocol buffers. gRPC services, okay, which defines the guidelines of remote procedure calls. Image service is used for pulling the images from the repository, basically. So when you create an image, right, for the container, what you do, you pull an image, and once you have your application image, what you do is you have to upload it to a repository, like for example JFrog. It's a image repository. So the image service will pull that image. Whatever you have defined in the configuration, it will pull that image from the repository. Or it could also remove the image. It's an image service. The runtime service, so sorry about that. The runtime service contains the remote procedure calls to manage the life cycles of the containers and pods. Okay, some methods, CRI methods, as you can see, they are just abstract methods, and each container is supposed to provide its implementation so that when the kubelet gives the command, create container, so the Docker, if it's a Docker would know how to create a Docker container, okay, or Vagrant would know how to create a Vagrant container. So some lifecycle commands. So that is about container runtime interfaces. So one more time, what it does is defines a set of protocol which every container runtime has to implement and provide its specification, like what it needs to do, like implement the method. Okay. Next, we are moving on to pods. Basically, everything, the entire infrastructure is so that you could have pods up and running all the time in the Kubernetes environment. What you do, you create a deployment. When you create a deployment, Kubernetes creates a pod to host your application instance. So a pod is a Kubernetes abstraction that represents one or more application containers. Like in one pod, you could have storage, which is shared across different containerized apps. Each pod has its own unique IP address, and it has one or more containerized applications. And one worker node, can have more than one pods. So imagine the number of containerized applications you could have in Kubernetes. And you can have multiple nodes, right? So again, one pod can have multiple apps, containerized apps. One node, let's go back here. One node can have multiple pods, and in a cluster, you can have multiple nodes, right? So imagine the storage. Okay, some commands that Kubernetes provide using the kubectl. Kubectl is the CLI commands, which is there. Okay, we'll see some in action. So get pods, describe pods, create a pod, delete a pod. Okay, exec, run a command on a pod, logs, forward a port forwarding, like exposes the container. So you could either use kubectl to create a pod, but generally what happens in production environments, we use YAML files and then we apply the YAML files to create the pods because you can create more than one. Okay, let's see an example. This is a sample YAML file. Okay, it creates two containers. Okay, one is nginx and another one is a database container. One uses MySQL, another one uses nginx latest version. So this is the image which the image service will pull from the repository. And this container will run on port 80. The database container, the MySQL database container, will run on port 3306. So if this file name is appdbpod.yaml, what you would do is kubectl apply -f is the parameter for file, and you'll give the file name. Okay, so this is just a sample YAML file. So some kubectl commands. Now let's go back to the terminal and see some. Okay, so let's go back here. Okay, and the terminal. So I just ran a command like kubectl get services. In my previous video, I had shown you the commands to download Minikube. So if you haven't done it, please download Minikube. It's available freely to download. And then you have to run Minikube start to start the Kubernetes cluster. All right. So let's see. Oh, one more thing. What I have done is created an alias for Kubernetes, a shortcut, so that I don't have to type kubectl all the time. I can just say K and it works. Okay, so the command to do this is alias K equal to, I have to give the full path for my Kubernetes, which kubectl, it's this. So alias K is equal to, in single quotes, you will give this. So it actually saves you time. Go here, go here. So this is the command. This is how you create an alias. So now every time I don't have to type kubectl, and I can just use a shortcut alias. So let's see some commands in action. So very simple, K version. I could also do kubectl version is the same, just to give you, it's the same, right? Get nodes. See how much time it saves? Just typing K. So it has it's a Minikube, which is the status is ready. It's the control panel, the first one which we saw. It's running since 25 hours, and this is the version. Okay, now let's create, hopefully this works. Let's create our first deployment. So you create a deployment. It's a sample which is available. This is the image you're pulling it up from Google repository. Okay, Kubernetes Bootcamp version 1. Let's see. I hope this works. Okay. Oh, there it is, created. already. Now, some more commands. Let's see. Okay, let's try this. Describe deployment. Oh, but there's no my deployment there. So let's see. Create deployment. Oh, yeah. I did. Kubernetes deployment. Kubernetes bootcamp. So this is the deployment that we created. Oh, there it is. Look at that. Right? So describe deployment. So you just created a deployment previously. What it is, it's in the default namespace, creation date, time, replicas 1, strategy, rolling update, pod template. It's here. Conditions available. Type is normal. Okay, so you get a detailed information. Let's see one more. No, I don't want to scale the replicant to 3 because it's Minikube. Create a new service. Okay. Selected app. Instead of my deployment, I will have app equal to my deployment name is Kubernetes Bootcamp. So I am creating a load balancer service. Oops, selector unknown. Okay. Is it equal to that? Or dash app. Okay. Let's see the help. Load balancer, that's what we were using. Okay, so and what do we do? Well, let's do app equal to. All right, I don't think it likes it. Okay, but anyways, we did not create the service, but let's see if there is any service that is already running. Oh, cluster service is running. Cluster IP service is running. All right, so external name, load balancer, my service flags options. Okay, I'll find out this about next time and we can discuss it next time. But this is all for about today's Kubernetes lecture. So what did we learn? A brief recap. The architecture, we just went through it. We went in detail. What is a CRI, which is the runtime interface, which is nothing but a contract, which every CRI shim has to implement. So the kubelet talks to CRI shim, which acts as the server, which provides actually the implementation of all these methods, because there are different containers, right? Different applications. So that is there. We talked a little bit about pods. What is a pod? Each pod has its own unique IP address, shared volume data, which is storage, and one or more containerized applications. Some command with the kubectl gives kube get pods, describe pods. So let's see, get pods, what does it give? What does it have in our environment? I have one pod for the service that I just created, the image that I just deployed, the Kubernetes Bootcamp, which is running right now. Now remember, before you try all these commands, you have to run minikube start, okay? Because you have to start minikube, you have to start the cluster, which will start the master node and all the services that it needs. All right. Hopefully some things are more clearer now after listening to the lecture. If you have any questions, comments, suggestions, feel free to write around the comments there on the channel. All right. Thank you all. Thank you for your time. Talk to you again next time. Until then, take care. Bye.